All right, so this lesson is all about base 10 exponents. You may know these as powers of 10. And so, what I need you to do is we're going to take a few notes on this skill to kind of as an introduction before we get into our iReady book. And so, what I need you to do is go ahead and find the next available page in your notebook and go ahead and title this base 10 exponents and put the date. Go ahead and pause here until you do this. All right, so we're going to be talking about exponents. And if you remember way back when we talked about volume and we did something like inches, I'm going to go to a new little, you don't have to write this right here. I'm just going to kind of write this down here at the bottom. You remember when we did inches times inches times inches, and we ended up with cubic inches? Do you remember doing that back when we did volume? Well, we're going to do the same thing with this little 3 being the exponent, but we're just going to relate that to numbers. And in 5th grade, we're going to focus mainly on base 10. So 10 is going to be the base that we're going to be using. However, I will show some of you guys a little bit above grade level, which is 6th grade, when you get to do different numbers other than 10. But for now, let's just focus on 10. All right, so what I'd like for you to do is I'd like for you to draw a big 10. That's real bit, like at least takes 2 lines, and then a little bitty 3, like that. We're going to use 10 to the 3rd power here. This big number right here, this is called our base. Again, this is called our base. And this little bitty number right here is called our exponent. And I'd like for you to highlight those 2 terms to make sure those stand out. So we're going to highlight exponent, and we're going to highlight the word base. So base is the big number. No matter what it is, it's the larger number. And then the exponent is the little bitty number. And this shows repeated multiplication. So it shows repeated multiplication. Remember that if I write and I'm writing notes, you have to write these down as well. So it shows repeated multiplication. Feel free to pause at any time to get caught up. Shows repeated multiplication. All right. When we read this number out loud, when we read it, we're going to read it a couple different ways. You can do it either way. These are both acceptable. You can say 10 to the 3rd power. So 10 to the 3rd power. Or you could say 10 to the power of 3. 10 to the power of 3. Both of those are perfectly acceptable. Okay? So 10 to the power of 3. So I'm going to come down here. You don't have to write this little next part down here. Just want to go through a couple examples. So if I said, write this right here, how would you read that? 10 to the 2nd power or 10 to the power of 2. What about this one? What would that read like? Hopefully you're reading them out loud or in your head. 10 to the 5th power or 10 to the power of 5. What about that one? 10 to the 9th power, 10 to the power of 9. Okay, what if I change the base to be like something like that? How would you read that? 5 to the 3rd power. Yeah. 5 to the 5th power. 7 to the 3rd power, or 7 to the power of 3. So all of those are, just kind of ways, little exponent numbers. They have a base and they have a little exponent. All right, so if you guys can think about slime or, when you expanded that slime out, like when you were, you like to play with that. I know my kids did when they were little. You could pull that slime apart. Well, in expanded form, when we write these expanded form, it's kind of like we're expanding the number. You did a version of this in elementary school. So like in elementary school, you may have had the number 372. But when you wrote it in expanded form, you wrote 300 plus 70 plus 2, right? That's expanded form. This right here, the way we always write numbers, that's standard form, okay? And so we're going to do this with our powers of 10 here. Okay, so we're going to write in exponent form. We're going to write in expanded form. And then we're going to write it in standard form. Basically, we're going to take these numbers, these exponent numbers, and we're going to break it down into a few ways to help us really understand what these really mean. Okay? All right. Once you get that, make sure you go back and you highlight these terms. So exponent form. You'll also hear it very fancy called exponential form, exponential. It has the word exponent written right in it. So you may see it written as exponential form. All right. So let's do our first example here. And we'll do that 10 to the third power that we were talking about up there. So go ahead and write it. Make sure that just like when we did with volume, we made sure that cubic units or square and area when we did square units, that those little exponents are not as big as everything else. We want to make it small, and we always want to make it up here to the right. So you're kind of making it right up there at the top. All right, so if we read this number out loud, we would say something to the effect of 10 to the third power or 10 to the power of 3. But expanded form, this shows repeated multiplication. So what this is telling us is that we have 3 tens that we're going to multiply together. So 10 times 10 times 10, 3 tens. The exponent tells us how many of the base that we're going to be using. So since our exponent is 3, it tells us we're going to multiply 10 3 times. And you got to be really, really careful, because the evil distractor here, and what even my 8th graders, when I taught 8th grade, would used to get mixed up, is they would say 10 to the third power, and they would say that's just 30. They would try to multiply it. But that is a big no-no. That's not the case. If we have 10 times 10 times 10, what is 10 times 10? It's 100, right? And 100 times 10 would be 1,000. And so 10 to the third power is actually 1,000. Kind of cool. You could also do this in terms of place value. We've been talking about the last week, we've been talking about how everything is 10 times greater and 10 times less. So if you start right here with 10, we could say tens, hundreds, thousands. And so we could use our place value chart to even kind of count out what this number is. Some of you are going to start noticing a pattern between the exponent and the number of zeros in there. So that's something cool to watch for. All right, we're going to go ahead and draw a line underneath it. Let's do another example. This time, let's do 10 to the second power. Feel free to work ahead of me if you think you're already figuring this out. But this is telling me I have 2 tens. So 10 times 10, 2 tens. And what is 10 times 10? That's right. It is 100. All right. Let's do another one. Some of you are like, oh, I'm figuring this out now. Let's do 10 to the fourth power. 10 to the fourth power. What would that look like in expanded form? How many tens are we talking here? The exponent tells us 4. So 10 times 10 times 10 times 10. All right? So if you're using your place value chart, you're saying tens, hundreds, thousand, 10,000. Or 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Or, once again, you're starting to notice a pattern between the numbers of zeros and the exponent. Let's do 10 to the 6 next. Let's do 10 to the 6th power next. How many tens are we talking about here? Should be talking about 6. 10 times 10 times 10 times 10 times 10 times 10. You can tell why nobody wants to write all these dang tens. Likewise, when we get these really big numbers, when we start talking about space and we start talking the distance away from space, they may have something to the 19th power. And nobody wants to write 19 zeros out all the time. Can you imagine if you're writing a scientific paper and you're talking about things that are really far away in different galaxies? And then you're talking about these and they're like, oh, this is 10 to the, 5 times 10 to the 21st power. Nobody wants to write 21 zeros out to talk about how far this is away. And so they have this shorthand way. This is also called scientific notation because they will write this in a shorthand way so you don't have to write this many zeros out all the time. 10 to the 6th power is shorthand to write 1 million. All right, so 1 million. And then you could, instead of writing 1 million, you could just write 10 to the 6th power, and it means the exact same thing. All right, 10 to the 5th power, that's our last one. Go ahead and pause me here and finish that one completely on your own. See what you can do with it. And you should have 5 tens. 1, 2, 3, 4, 5, 10, 100, 1,000, 10,000, 100,000. 100,000. And that's the kind of the what this means. So when you see these exponent numbers, whatever you write right here means this right here. It's just a shorthand way of writing it. 10 to the 5th power is the same as saying 100,000. It's the same as having 5 tens multiplied together. All right. To show what this would look like, I'm just going to go to the next page real quick. But you don't have to write this part down. I'm going to kind of write right here. If you had something like, say, 2 to the 4th power, that wouldn't be 8. That would be 4 2s. 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. And so the answer to this would be 16. So that patterns of zeros, if you start to notice anything, it only works because 10 is such a fabulous number. Okay, it doesn't work when any other base is that number. So that's why I'm not teaching it that way. I'm teaching it the way that you can use for any number, not just one specific number. Okay, all right. Let's add just a couple more small things. Let's kind of, you might hear this called evaluate. Evaluate is a fancy word that means solve. You may hear evaluate the expression. And in this type of expression, let's write let me go to pen. Let's write 5 times 10 to the 2nd power. Now, I'm going to ask that you write just like I do on this one. Okay? When we start talking about order of operations, we're going to learn that exponents come first. What is 10 to the 2nd power? 10 times 10, right? Which is 100. We're going to write that on this line right underneath it. And then we're going to say 5 times. We're going to bring everything else down. And what is 5 times 100? Right? 500. So this is 5 times 10 to the 2nd power, another way to write 500. Okay? Easy. Let's try another one. Notice I don't have any equal signs in here, by the way. This is an expression, not an equation. And so expressions don't have equal signs, but equations do. So we're going to write expressions. Let's write 3 times 10 to the 3rd power. All right, 3 times 10 to the 3rd power. Okay. What is 10 to the 3rd power? 10 times 10 times 10. So 10 times 10 is 100, times 10 is 1,000. And then 3 times 1,000. What is 3 times 1,000? Yeah, 3,000. So again, this right here is a shorthand way of writing that. What about 4 times 10 to the 6th power? Why don't you pause it and see if you can figure this one out? Okay. All right, so if I am unpaused, that means you already have an answer here. So 4 times 10 to the 6th, 10 to the 6th happens to be 1 million. So 4 times 1,000,000 would simply be 4 million. And the more zeros we start to get, you start to see that this right here is an easier way to write that. Okay? A little bonus real quick. A little bonus, a little above grade level knowledge here. Let's do 5 to the 3rd power. All right. So what would that look like? How many fives are we multiplying? 5 times 5 times 5. Be careful. Don't just say 5 times 3 is 15 because that's adding them, not multiplying them. So you've got to be really, really careful you don't fall to that evil distractor. Okay? All right, what is 5 times 5? Right? 25. And then 25 times 5 is 125. So 5 to the third 5 to the third power actually equals 125. So that's why you got to be really careful and why I'm teaching it where you have to list them out so you understand exactly where this is coming from. If you don't, if you just look at the patterns of zeros and attach zeros on the end, that's great, but it's not going to help you when you get to 6th grade and when you start getting numbers other than 10 as your base. All right, well, this is our lesson for today. Tomorrow, our goal is to get into lesson 7.2 into our book, and we'll see how this really starts to apply to these bigger numbers. All right, awesome. Hopefully, if you're watching this, you are feeling better from the day that you missed, and we'll see you soon. Bye, guys.